Okay, here we want to find the antiderivative of this function. Okay, so as you can see, this long looking function, okay, which is pretty simple. Well, I'm just gonna do this using integration by part formula. All right, and that demands us to maybe choose a function to differentiate and then choose a function to integrate. And looking at this, this is just a linear function. If we differentiate this once, it is going to become a constant, and that means it's going to be easier, or that would be a better choice for the differentiation. So in a previous video, I integrated a function which demanded this integration by part formula, of which I made use of this di method, all right, a table method for the formula, which we are just going to learn right now. So first of all, you put a di and then you put plus and minus. You may need to put lots of rows, okay, just be alternating the sign, plus minus, depending on how many times you will have to differentiate and integrate till you get something nice. For example, in this case, as I said, let's choose to differentiate 2x plus 3, and then we choose to integrate the cosine of x. All right, great. So you notice that the derivative of 2x plus 3 is just going to be 2. Now if we are to continue, okay, we will still alternate the signs, and then we will still continue differentiating. The derivative of this will give us 2. The derivative of 2, we know, will give us 0. So when we have this kind of constant, all right, then we know that that's where we have to stop, since the next time will just give us 0, which will be insignificant after multiplying. You would see that. Okay, great. Now let's find the antiderivative of the cosine of x. The antiderivative is sine of x. Don't be confused. If you differentiate sine, you get cosine. So the antiderivative of cosine will be positive sine. Okay, great. And now that we're done up to that level, let's see something. What we usually do is we multiply the diagonal, this and that. Okay, we're going to multiply them together, and then we also multiply this last row. And this time, when we multiply, we are going to find the antiderivative of the product of these two entries in the last row. So that means that this will become the integral, this integral will become, well, let's multiply this diagonal. We're going to have 2x plus 3 times sine x, right? And then we say multiply this together. When you multiply it, you integrate it. So this is minus 2 times sine of x. So I can put it here as minus 2 times the integral of the sine of x, and then you put the dx over here. Okay, great. And now what we have to do is to just find the antiderivative of sine of x. Of course, that's pretty simple. This is going to be equal to, well, we still maintain this because there's nothing we have to do there. You know, there is no operation on that. Okay, great. So this is minus 2. Take note, what is the integral of sine x? Well, the antiderivative of sine x is cosine of x. If you differentiate cosine of x, you get negative sine. So the antiderivative of sine is negative cosine. So when you have negative cosine times this negative, it becomes positive 2 times the cosine of x. And this right here is it. So we can add an arbitrary constant. I didn't add it. Let me just add it, right? It's not 0, it's an arbitrary constant. It could be any constant at all. So this right here is the antiderivative of that function over there. Okay, great. Thanks for watching. Please subscribe to my channel.